That's a good start. Now, let's look at this again. 7 spokes. That's 1 spoke going right down the middle of that. If we split it in 2, we can build only this piece, duplicate once across, and then all the way around. That's pretty good. Pretty good. So let's get these curves in first. That's what I want to do. I'm just trying to decide how to do it so I know it's going to be nice and clean from the very beginning. So for that, I will work on this layer. I will go into layers. And I want to create a symmetry plane. So I'm going to set this symmetry plane for this specific layer to be linked to that point. And I want the plane going across the wheel. So that defines, let's say, the diameter, if you want, however you want to call it. So it's going to be that plane for me. The reason why I'm doing that, you'll see it soon, is let's say I get myself a nice curve in here, and it looks like that outside curve is, let's say that spoke is twice the size of that opening. So I can go that way once more, roughly here, pop a line in there. They also look quite straight, if I'm not wrong. It's a very similar design. You see they're opening ever so slightly to the outside. That will do. And now let's turn on the symmetry there. And there we have it. That's the magic that I'm looking for. You see that one spoke seems kind of that size there. The other one will be the same size. And then we've got the opening there. So if I take myself a curve that's almost the size of that hole, I can bring it across, up. And we see that that is happening quite close to the bolt hole, the hole for the bolt, the lug nut. So got that in there. Then this curve, I'll move its pivot there, and I'll try to generate myself another one here, which is reflecting the fact that I want to go 7 times around that circle. But first and foremost, let's do a small offset of that. Let's move it out first. There we go. And I'll do, let's say, a 5mm offset of that. That's that. And let's get this central area in. So that central area seems kind of like the middle there. So let's go like that. I'll open this as well, ever so slightly, but not as much as that one. That's good. So I've put everything on a plane here, so it's easier to work with. Let's get this curve down here, across. I'll make it symmetric. So that CV goes kind of there. I'll make it a degree 3. Get those down, center the pivot, and scale them out. That looks good. So that will be the one spoke. And now let's get this curve. And let's do the same thing we've done before. Let's build a revolve here to that vector. And I'll get this down to 360. I'll make sure we've got 7 segments. I'll template these. These surfaces, I will template them because I don't need them at the moment. Neither do I need this one because we will be working on this one. So I'll project onto it in the side view these curves. And I'll make sure that I have the same 5 mil width here at the top as well. So that's going to be done by doing tubular offset of, let's say, for the sake of argument, let's give it a 7 mil because we will have a small radius there. So I just need the curve and surface. That's about it. This current surface, actually, we don't really need it. And we will be keeping only a certain portion of that surface, i.e. this bit here. That's the first part of the spoke. Now we've built this other surface here, this other curve, and I'll do a surface off of that, similar to this one. So let's do this one next, and we'll devise one off of this curve. Same story. These get the templates, and onto this one I will be projecting these two, and my first go-to way of building this would be a skin between that current surface, and if we untrim this, it's going to be between these two. Same front wheel layer, I'll do the same thing like on this layer. So I'll go in and do the symmetry. So I'll set the symmetry plane Might hide away those templates, so we don't need them for our purpose here. They have served their, let's say, visual purpose for the moment. The rest we keep. Actually, let's get those out of the way as well. It can be easier to read and understand everything. Now I'll trim this surface back. So this is getting us. Sorry guys, I do like an Aston Martin, so I was checking these things. You can see that it's actually the other way around. It's deeper in this area and shallower around here. So we'll have to adjust that plane a little bit. Thank God we've got the history working for us, so that's going to be an easy task. That means that we will be literally taking that curve there, and we will be rotating it the other way around. So in X, shallower to the center, deeper on the outside. Move it in as well, so it's got a bit more movement in there. This is to become a really good modeler, because you'll see a lot of people saying this is what you have to do to become a great one or whatever. In my opinion, the first thing that you have to be able to understand is what you're looking at. If you don't understand what you're looking at, whatever it is, a sketch, picture, a blueprint, if you don't understand and if you cannot read those proportions properly, then you're just a person who has learned to use a software. And the industry doesn't really need these guys. You need to be able to communicate, to understand what people want from you, and work with that. That's what you have to be able to juggle with, basically. That's what you need to do. So modeling from pictures, blueprints, everything is building that thing up, but you always have to be able to read a proportion, to read what you see, right? Understanding shadows, understanding light, where you've got a break, where you've got a radius, all these things. These are the things that make you actually valuable. It's not being able to use alias. It's not about alias here. You can do the same work that we're doing here in ISON, or some people do it in Rhino. But the great people actually read a sketch, see it, interpret it, and bring the feeling in there. Those models will have all the features a sketch is showing. It will show them in a very similar proportion to the sketch. You know, sometimes the sketches are a bit different, if you want to put it that way. They've got a lot more emotion, but you're a model, and your model maker, as a digital model maker skill set, has to be able to communicate the feeling that you can get there. So I will stop my rant on this. Going back to this topic here. What I'm seeing here is that this surface that we've got here, let's say, which is the base of this gap, we could actually use it to be the surface that's running all the way down there. Because you see we have this dish here, and we could actually use that. But we will explore it a little bit later. It's just a hunch that I have. The way I see this is curling in and going in there. You will not always be able to go to the actual car if you're modeling one of these exotics, but you'll have to start getting this understanding for the feeling of those things that you see there. Okay? So, let's see what we do there. Let's see where this takes us. You see here, everything is sitting on that circle. I'm just curious if this all is a rotated surface, a revolved surface, or we've got actually that mountain, if you want to put it that way, going in there, and this is a big blend from one side to the other, and you've got actually here a dip. Who knows? But let's try it that way, because it does feel like we've got here a little valley which ends up in that radius going out there and washes out in this area. Let's see. Let's try. So I'll go with that assumption then. That means at the same time we've got to work a little bit different, because from here to here we've got that going on there. It's a bit deeper, it's a bit more shallow, it's coming out there, and then what we have here is actually a different curve meeting up with this one, and I think we have a radius here. It does look like it's dipping in there. So to do that, just hide this because I don't need it at the moment. I will take one curve like that. That's the center bore, so I'm wrong here. If you haven't noticed, shame on you. No. So let's take that node, that curve, and move the pivot all the way there. Let's move these up here. These we don't need anymore. And we'll have to duplicate this again. So edit, duplicate object. Let's do rotation 4. Do the scaling 1, not -1. We'll rotate it in the y-axis 72 degrees. And let's get instances in there. That means that these are, let's see, this is virtual geometry. Let's put these on a different layer. And when we adjust this, in theory, these would follow suit. Okay, so let's go back to this here. Now we've got the center bore there. We know that we should be more outward. So this curve is 64, that's 128 diameter, and these are 5 sitting on that. So let's jump back to this. Now we're going to get closer to these proportions. So we see that there isn't much distance between that circle and that one. So this means for us is that this curve moves. Let's say we increase its size and move it up. First to sit where that hole is sitting, and then let's say 4 mil higher up. That will be our opening then, that surface there. Now, if we add these surfaces onto this layer here, turn on the symmetry, we will be seeing the first spoke, which is really cool because now it starts feeling more like what it should be. I'll take that curve and I'll rotate it a little bit back. This is too shallow now. And you'll see that modeling a lot of the times is a lot of trial and error. And let's move the pivot. Got a radius here. And we will have to emulate that section as well. See, this inner bit, that's very important. And this thickness looks almost like the width that we have there. So that's a very good thing. So I'll use my dynamic measuring tool. And I have here 25 millimeters. Hide this away and make sure that I take that curve and offset it by that same amount that I've seen there, 25 mil. The other way around. So here we're pretty good. Let's move this back here, rotate it, more like that. So it's still opening a little bit to the center. That looks nice. This curve moves up and gets flatter a little bit. That's it. Now we don't need this anymore because we have that in there. Got that dialed in. Let's bring this back here. And now, if we go back to this, we have that, and then that. So let's look at those things together. And we see that we have a little step there. So this is hitting actually a little bit more inboard, this edge, compared to where the back of the spoke is hitting that same surface there. So let's do that. That means that we have this here. My rough guesstimate is that we will be landing somewhere here. And that is that surface. And here, that is more or less twice the size of that. It's 1.5. So if we have 5 mil, 6 mil actually, in that area, let's do 9. So I'll get that line dialed in there. Whoops, that was a bit confusing. Let's do 10 mil. Let's rotate this. Oh. Let's move it first in the correct position. It should be sitting there. Now let's rotate it in on the x-axis. That's it. Here we shouldn't have less than 2.5 mil. So let's take that curve, offset it, let's say 3 mil for the sake of argument. We know we're fine. That's good. So that's a nice and stable rim. That's it. Now this goes in there. These two curves go onto the curve layer. Let's move their pivot also there. And let's generate our nice revolve. That's it. So now we're starting to resemble more and more to what we are seeing there, which is really good. And in here, we will do it a little bit different. So we see we've got a nice sweep, which is not hitting that surface, which is also nice to see. This also means that our surface here should come a little bit more outward. Still keeping that same feeling. And we can take these points here and move them down a little bit inward. Still got the space, that's good. Just can jack this up to here. That's good. That is good. Because this will allow us to do the following thing. That there, which is important. And for that, what I want to do is actually take that surface, untrim it. Now I'll do tubular offset on that surface. This one here. Let's give it proper radius. I just want the curved surface. Let's see, 30. Looks like it. For the moment, I'll do a blend, freeform blend from that edge there to that surface and to that edge there. So the curvature to position on that. The inner surface is actually touching that point as well. Very interesting. As I said, we need to really understand what we're doing here. So I can generate one more revolve to add it to that one there by shift clicking that surface, that curve there. So that's looking good. Might reduce this by a little bit. So instead of being 30, let's go 28. I'll hit this up here. That's nicely jumbled up. Tangent there. Busy. No, let's not do that. Okay. And as you've seen here, these are negative, so let's get that skin working the correct way. Okay, so this, trim it back here, you can template it for the moment. And let's add these surfaces where they should be. And let's intersect this surface with this one. edge there, just to make sure this is nicely closed. We'll have to fine tune those to get the correct intersection, and then we will rebuild these surfaces to be nice and proper clean. Now the next thing that's important is to have the drafts, because we have some drafts running inboard. So I'll untrim this, put a draft on that surface in the Y direction, make sure it's a single-sided surface. Let's give it just 100 millimeters length. We don't need that much. We know that we've got 25 at the back, so 50 would be also enough. It's good. And we need to give it some draft angle. Let's stick with 5 degrees. This draft angle, it all depends on the manufacturing method, so this will be given to you as an information when you build these things, but it's also in your design modeling. It will show the fact that you do have an understanding of this topic. Same thing on this inner edge here, but the other way around, the angle, so -5. That's good. So things are shaping up very nicely. So that's the one spoke. It's all cool, all nice, but we still need to get to the center there, where we actually don't know where the center is. So let's start doing these things. So we've got the center bore. I'll get that line up there, extend it back to the ET. That gets also extended back to that point here. We're coming to this point. This will be the hub. So these curves. Here we don't need 7 bits of that, so let's put the pivot here and let's rotate that, let's revolve it on the same bit there, but let's do only 5 segments. We've got 5 lug nuts. That's cool. And let's see what this depth is here. 13 millimeters. That seems plausible. Let's take that note and move it back by, say, 3 millimeters. And you see everything adjusted with it. This is why I like the instance, working with instances there. Okay, cool. Now we have that center bore there. We have that. Now let's look at the picture again. The lug nuts. If it's 35 mil, that, and let's look at this canvas. Or I don't know where that canvas is, so I'll jump back to here, 35 mil from that base there. That means that we will be looking at 35 mil from here outboard. And then what I want to do is go up like that. This is actually working with a reference, more or less. I'll go up here, so it's sitting a little bit more outboard compared to my lug nut, just as it does here. See, here it seems to sit below it towards the center, so let's do that in here. Let's move this down to that point. This curve we adjusted to that point there, and we have this curve here. So let's bring this back here. Let's give it some crown. Let's extend this curve quite a lot, so we do get an intersection there, and these will be sitting quite close, so that's looking promising. You'll have to also make sure that all of these curves sitting around here, that they share the same center. So let's take these curves, delete any history on them, turn on their CVs, take all these CVs. So I was saying that we should take all these CVs and move them so they sit on the plane on which our vector is sitting. So we know everything is done correctly. And then on this layer, we align the same symmetry plane like that one. So let's go into layers, symmetry plane, set symmetry. Sitting correct, so it's all good. Now let's go back to this. Take that curve there, move its pivot around there, generate one more revolve. Probably you've noticed we are generating a lot of revolves here when we're building wheels. This is actually the fun part of it. Once you get the hang of these things, at least to me, these are becoming quite nice to work with. So let's extend that curve a little bit more. There we go. Actually, we should intersect our center bore with it. And let's trim this bore back. let's intersect this with these two surfaces. Keep this, that bit there, that bit there. So now we're starting to resemble more and more to the situation that we've got in here, which is good. That's actually what we want. Let's put all these surfaces in here. All the curves on the correct layer, the objects where they belong. So once you place a surface, that doesn't mean that you've placed the object as well. That's another important bit that we need to remember. Now, let's see, we've got that curve there. Move this pivot down here. I'll generate one more revolve, as you've probably guessed so far. And we'll go here also with only 5 segments. We don't need the 7 segments. That's good, because then we can intersect these drafts with that surface there. And then let's see the rest of the surfaces we're missing. We can intersect the same drafts with that surface there, that surface, we project on top of it a revolve there. So this allows us to trim this back like this. We keep these surfaces as is. Actually, they have to get intersected with the hub. These get to be templates. And we keep on going like this. Now we've got all that. These bits hold a very important number in them. So when you bring up the history, the segment, that number, I'll copy paste that, because what I want to do is take these surfaces, move their pivot over there, and then go into duplicate object. I'll generate only one in the Y direction that way, and I'll put a minus in front of that. And if I'm correct, then I will have a spoke of that move across there. So again, I'll copy now. That's the correct one. I need one. Let's duplicate it like that. That's the bit that I was missing. So I did duplicate object, Again, I'm doing it wrong, so let's go again. Doing it wrong because here on this side I actually need the mirrored bit of that. So let's duplicate that object. I'll just mirror it across the YZ plane. So that's relative to that and to the plane. So let's see what plane I'm using here on this layer. So front wheel, layers, symmetry plane. So we've got Y and X. That's why it didn't work. But if I'm wrong, then someone will correct me. But I'm going to correct myself here. So Y and X. Let's see this. That's the Y direction. That's the X direction, the Y direction. I'm a bit confused here. Since I've moved my plane, I'm a bit confused here, so bear with me. That was it. I'll do a check here. We should get tangent connections here. If that's correct, then we can keep on going. That's perfect. Okay. Now that we've got that, we've got the center. Now we'll rotate this the Y direction by the amount that I was talking about. This is very helpful because this bit becomes this bit here. That's important for us to be able to achieve what we see here, get that in, dialed in there, and that's interesting, to say the least. So back to our reference images. That is getting very close to that line there, so the center of the blend between the two should sit somewhere around there. Get this reference dialed in. And we also need one more reference, and that will be from the center to hit that point there. Because that's going to be, say, the half of our spoke. This is where we will be cutting what we generate here between the two. And that's very, very important. So that goes somewhere around there. Let's build a radius between these two surfaces. Let's increase the size of that kind of to this point. Let's say 38. Now, what I want to do is take a key point curve, and I'll take perpendicular line, and I'll change the settings to be true from the curve, and the curve that I'm using will be this here. So I'll go this way and hit it in that direction, then I'll go the other way around, hit it in that direction, and now I can project in the side view these curves onto these surfaces. So what we're doing is actually building that valley there, closing this up so we get this done and working. So we can actually trim it into two bits, mirror it back to this side here. Once we've got the complete spoke mirrored, that's when we rotate it, get the 7 spokes. A bit complicated, but it's stuff that you need to do to be able to proceed with these things. Also, this bit will be important here, this theory point, going from here down here. Let's project that line onto that surface there. Take that point, back there, this one down there, and we'll have, let's say, the theory between these bits here. So for that, okay, now that we have that, we can go ahead and try this. So I'm going to hide these curves and build a blend, trying to emulate what we've got here in this radius. Line on both ends, curvature. Now let's start adjusting this. Lock the shape controls, get closer to what we have there. we will be adjusting this anyway, to keep the amount of work as low as it can get. So we have that there. CV layout on the radius is nicer than here, so let's work with that. So I'll delete the history on that, realign it there. That's about it. Starting to look more and more like what we have in here. Okay, now let's build this here. So we've got that. We need to get this working properly, so we'll bring these back. Now I've adjusted those curved surfaces, and guess what? Everything went with it, so it's not good. Let's bring this back. So I'll align these to that edge. That's okay again. It's all good. We've got those things working. Now we need to get these ones working as well. So that surface is that surface. Let's project onto these two, these curves. Let's build the blend. these two. I'm not so keen on this here. This is the odd bit about this here. Looks like here we've got an intersection with this surface here. It's going this way, which is interesting. Let's build a nice radius between this surface and this one. Let's see where this takes us. Let's increase the size here to get us closer to that point where the radii start on the spokes. That's more or less it. Say 49.5. 0.8. I like to coordinate that start of that radius with this one. Okay, now this is getting more interesting. What I can do is actually go ahead and do this. So that surface can get to be a template again. We have this surface here, which is basically this inner one this way. One of the reasons why I don't really like the option of using draft surfaces is that they are not reliable. A lot of times they get rebuilt and then they do whatever they want to do. So try to build here a clean surface. It's one generation on 2 rails. That's it. And I'll turn on the explicit control and keep these as simple as possible. So that should do it. And now let's turn on rebuild on both so we get cleaner surfaces. That's it. Now I want to extend this surface here. Perfect. That way, this way. Now we'll be doing the same thing with this one here. The reason why I want to do this is I want to find the intersection between these to have a proper surface there. So same thing again. I was aiming to get you a nice short video with all the basic stuff that you would need, but It doesn't look that way, does it? So if these intersected this surface, this intersected with this surface here, and both of these intersected with these. We don't need them. They're just standing in our way here. The good thing is that we could generate skins like these from here down to that edge there. Let's template these again. Let's do this again. So from here all the way here. All the way around. Let's bring this in like this. Same here. Let's use that curve here to set our reference system correct. Now that we've got that, we can go ahead and build that blend there that we're missing. I'll just build a blend curve here. From that skin to the other skin. Get it looking right. So pull up the history of it, line it correctly. That's it. And let's build that surface in there. Make it even easier for us. So side view projection onto that base surface with that blend. And now we know we're sitting correctly. Let's do this type of surface from here all the way down to that there. Do a default on both. Set it up like that. Actually, even easier. Blend this. From that to that. And I'll go curvature to position. Set it up like that. freeform blend this to this. No, that would be it. This to this. Get them working. Curvature on both sides. That's perfect for our task there. Let's see the highlights on these. I'm sure they're really bad. Yep. So, what do we do here? We have to build correctly. So, let's take away these. Let's look at these. What's wrong with them? And let's start adjusting that. So here I will decrease that to 5, make it just one surface, and I want to clean this up first. One surface with one span in it, two spans in it, and I will work that surface manually a little bit. So I'll go ahead and turn the degree up to 5 there. So what we are missing here is actually this. We are generating a massive dip in this surface here. So when we look at the CVs, here on the side, they're looking good. And once we are away from that, they're getting awful. So, freeform blend this. And let's take care of that surface. So that gets a degree 5. We will slide some of these CVs here. So gets to slide a little bit up. That slides a lot because I want to align this hull with that one. Same on here. And then the same with the other ones. One clean CV. I'm looking for a clean CV layout that gives me the quality in the surfaces. So once I have that dialed in, then we can start talking about other topics. Now, these CVs. Could also slide in a little bit just to align these other ones to make them sit clean and nice. This hull can do with a bit of fine tuning, so that loses its history. And now I go into planarizing these hulls. That one gets done like that. This one gets done like that. This one as well. There we go. That's kind of cleaned up. Now let's realign that blend to that surface. That blend to that surface there. Because now we want to take care of the dip there. So what we will be doing is looking at these in transparent mode. And we will take that hull, start pulling it out in the Y direction. Till the transition from one side to the other looks good. Same here. I'll be pulling these out. Start seeing how these start to clean up. Still not optimal, but it's getting there. We might as well break away from the connection there and move this out. Some more cleanup will be due. So that's what I'm doing there. I'm just moving these CVs around so the transition from that area to that area gets cleaner. So this is already better. Now we have to take care of this connection here, which needs to move out in the Y direction as well. Once these align, we will have nicer surfaces there, and it's not a problem that we've got that break there, as we will be running a radius around here. So that we don't need, that we don't need either. Let's trim the surface back with that. Curve. Same these ones. Turn on the patch precision on this one just to control something. That looks good. Looks clean. Cool. So We don't need these curving surface here anymore. Or do we need them here? We do have what we need. What we do need now is that curve moving up like that. This surface actually intersecting this one here. Now we need to bring back this. So we don't need these surfaces anymore. Nor do we need those. Don't need that either. Now let's start having fun with this. This front face, 7 bits of it, so that's good. Don't need this front one either. What we do need is this template here. And we need to look at this picture. So we don't have a close-up there. I would project that curve that we had in there onto one of these surfaces to generate what we need in here. So same 5 degrees. I'll make a profile of this along this. And what I will do, I will generate, intersect these two, extend this back to the intersection point. What I want to do is actually generate here fillet between these two surfaces. To finish this up. So we've got starting point, I'll keep it as extend. Now what I'll do, I'll make sure to keep it as a variable fillet. Pop an endpoint there on the line, and then play with this so we almost make this bit disappear. that's it. It looks pretty round to me. Let's intersect this with this. This stays. That's all we need. This one gets bound. Cut back these two, and this surface, they will intersect that one there. And we're slowly getting closer to finishing the main volume of this spoke here. It's been a long road, but it's rewarding. Let's extend this to the point where we can project that edge to that, and where we can intersect that surface with this one. So we keep that little bit. We can trim this back. That we don't need anymore. Just template it back. Let's untrim this surface now. Keep these bits like this. This here. And now let's generate some radii here. Save up first.